All right, in this video, we are going to do three sections, kind of similar to an earlier video. These three sections are all rather short, so I decided to do them all in one. So we're going to do sections 1.9 to finish up chapter 1, and then we're going to do the first two sections in chapter 2 as well. So let's begin with section 1.9. We are going to look at polynomial and rational inequalities. All right, so when you want to solve for a polynomial, or in this case, we're going to focus more on the quadratic purposes. If you are solving for a quadratic or a rational inequality, here is kind of some steps that we're going to use to help us solve these. So step number one, we're going to take your expression, set it equal to 0, and solve for x. For rational expressions, you have to also check where the expression does not exist. These are what are called our boundary points. So whatever your equation or your expression is in the problem, while there may not be a 0 in the problem somewhere, and most of them will have 0, you need to set it equal to 0, and we're going to solve for boundary points. Step two, we're going to take those boundary points and we're going to plot them on a number line, and we're going to pick test values that fall between each set of boundary points. Step three, we're going to plug the test values into the original expression, and all we care about is, does that number become positive or negative? The actual number does not matter in this case, and we'll see that in just a second. And then use the original inequality given and the number line form to write your answer in interval notation. If you follow these four simple steps on the next few problems, we will be able to solve all of these quadratic inequalities. So here's our first one. It says if you are given x minus 1 times x plus 3 and you want that to be greater than or equal to 0, how would we go about doing that? So here's a good first example to kind of get you, show you what's going on here. Back in the instructions, when it talks about the original expression, it's talking about all of this stuff here on the left-hand side. So once you get everything on the left-hand side, this is what it wants to know. Step number one says you're going to take your original expression, which is in factored form already, and you're going to set that equal to 0. Now, as we've learned in previous sections, you can now set both of those equal to 0. So x minus 1 equals 0, and x plus 3 equals 0. On the first one, if you add 1 to both sides, you get x equals 1. On the second one, if you subtract 3, you get negative 3. And I'm going to abbreviate here, but these are your boundary points, and that's what step one asks you to do. Step number two asks you to plot those boundary points on a number line in order. So negative 3 comes first, and then 1. And it also asks us to pick test values between each of those numbers. So pick a number less than negative 3. It can be any number you want to, but I usually go pretty simple. I'm going to pick negative 4. Pick a number between negative 3 and 1. I'm going to pick 0. And then pick a number bigger than 1. Why don't we do 2? Step number 3 asks us to plug all three of these test values. And we'll try to put them all in one big arrow here. You need to plug all of these into the original expression of the polynomial. So right here below, you can either do this in your calculator or you can do it on paper, it doesn't matter. But if you plug negative 4 in, you get negative 4 minus 1 times negative 4 plus 3, which is negative 5 times negative 1. Now, I don't care what the number is, even though it's not too hard to find. All you care about is it positive or negative? So in this case, that gives you positive numbers. If you plug 0 in, that is 0 minus 1 times 0 plus 3, which is a negative 1 times 3. Don't care what the number is, but I know that a negative times a positive makes that middle interval negative. And finally, if you plug in 2, 2 minus 1 times 2 plus 3 is 1 times 5, which is going to end up giving us a positive answer. And finally, step 4 wants you to go back to the original inequality. So if you go back to the original problem, it has a greater than or equal to 0. Well, what do you know about greater than 0? Well, we know that any number greater than 0 is going to be a positive number. So if you look at your interval, you only care about the positive parts. That's everything over here on the left and everything here on the right. And since there is an equal sign, you are allowed to put brackets on your numbers. In your homework, they want you to write this in interval notation. So down here at the bottom, I'll do that for you. It would be negative infinity to negative 3 with a bracket. Remember, when you have a gap in your interval, you have to put a union symbol, and then you go from 1 to infinity. This is your answer to this quadratic inequality. All right, so let's do a few more just for practice. So, for example, number 2. What if you have 3 parts you have to worry about? What about x minus 1 times x plus 4 times x minus 3 needs to be less than 0? So in this case, my original expression is this side. So I'm going to start with step number 1. And while some of y'all may be able to jump straight past this first step, I'm going to go ahead and write it out. You need to set your original expression equal to 0. And since it's already in factored form, you can go ahead and set all of those equal to 0. So x minus 1 equals 0, x plus 4 equals 0, and x minus 3 equals 0. Solving each of those, you should get x equals 1, x equals negative 4, and x equals positive 3. Plot all 3 of those on the number line in order. So let's see, negative 4 will come first, then the 1 in the middle, then the 3 on the end. Pick out test values. So pick out some numbers, and inside all these numbers, I'm going to pick negative 5, 0, 2, and 4. All 4 of those numbers need to get plugged back into the original expression. That's the left-hand side here. And so you would start off with negative 5 minus 1 times negative 5 plus 4 times negative 5 minus 3. And just to save a little bit of time, you can number crunch that if you would like. Remember, you don't care what the number is. You only care whether it's positive or negative. So just kind of really quickly, I know that that's a negative number times a negative number times a negative number, which is going to end up giving me a negative number. So my first interval is negative. Plugging in 0, you'll get 0 minus 1 times 0 plus 4 times 0 minus 3. So that would be a negative number times a positive number times another negative number, which makes this a positive number. So that's plus for me. Plugging in 2, this is 2 minus 1 times 2 plus 4 times 2 minus 3, which is a positive times a negative, which makes this a negative number. And finally, you probably can guess what's going to happen, but we'll check anyways. If you plug 4 in, that is 4 minus 1 times 4 plus 4 times 4 minus 3, which is a positive times a positive times a positive. So 3 positives make it positive. So you do alternate all the way down. The original inequality in the problem says less than 0. And what does it mean to be less than 0? That means you are a negative number. So you only care about the negative intervals up here. That would be this first one and the third one. Since there's not an equal sign, all of these numbers have to get parentheses in this case. And if you were to write that in interval notation, it would be from negative infinity to negative 4, union from 1 to 3. That is the solution to this polynomial inequality. All right, and like I said, I'm not going to spend a lot of time in this section, so let me just show you one where you have to factor yourself. That way you're comfortable with it. So number 3 says you're given x squared minus x needs to be greater than or equal to 6. Well, the first major difference you'll notice is 2 things. 1, it's not factored, and number 2, there's not a 0 in this problem. So we need to fix both of those in this case. So step number 1, I'm going to move the 6 over to the left to make this a 0 on the right. So that would be x squared minus x minus 6 is greater than or equal to 0. Okay, so first problem fixed. Next problem is we need to factor this left-hand side. So do your factoring techniques, and you should find that this factors into x minus 3 times x plus 2, which is now greater than or equal to 0. So now you can start doing your steps according to the problem. You're going to take your left-hand expression, which is x plus 3 times x plus 2, and you're going to set that equal to 0. Since it's now factored, we can set both of those equal to 0 separately. And yes, I do see my mistake. Let me fix it. Sorry. It's not plus 3, it's minus 3. It's going too quick. I apologize for that. So minus 3, minus 3. If you solve both of these, the first one you should get x equals 3, and the second one you should get x equals negative 2. Plot both of those numbers on your number line. So negative 2 comes first and then 3. I'm going to pick out some test values. So how about we pick negative 3, 0, and 4. I'm going to plug all three of those numbers into my original expression. Remember, that's the expression that's not with the 0. So that's this factored side on the left. So that would end up being negative 3 minus 3 times negative 3 plus 2. So that is a negative number times a negative number, which is a positive number. So that's plus. If you plug 0 in, that is 0 minus 3 times 0 plus 2, which is a negative number times a positive number. So that is negative. And finally, if I plug in 4, that's 4 minus 3 times 4 plus 2, which are both individually positive. So multiplying them together also makes it positive. Go back to your inequality. That's this part right there. It says it's greater than or equal to 0, so that is positive numbers. So we only care about the positive intervals in this case. That's the first and the third. Since there is an equal sign, I'm going to put a bracket on both of those numbers. So your final answer would be negative infinity to negative 2 with a bracket, union 3 to infinity. And that is the steps on any time you need to solve a quadratic inequality. So that wraps up chapter 1. So hopefully you kind of got the idea of what's going on there. Now we're going to move into chapter 2, and we're going to do first section 2.1, which is called the rectangular coordinate system. All right, so the first thing in this section is that I've got to run through, and this probably could have gone in the review chapter, but the textbook chose to put it here. This is going to be kind of a review on graphing really quick. So one of the basic ideas of graphing is that you can always plot points for your graphs. So what if I asked you to graph the function or the line y equals 2x minus 1? All right, so easiest way to do that is remember that you can just pick whatever x values you want to, and I don't make them too bad. I usually keep it pretty symmetric too. I'm actually going to pick x values of negative 1, 0, and 1, and I'm going to plug all of these x values into my equation in order to create the y values. You can either do this on paper in your head. If you need to use a calculator, that's fine. But if I plug negative 1 in, 2 times negative 1 is negative 2, and negative 2 minus 1 is negative 3. So that creates the point negative 1, negative 3. If you plug 0 in for x, you will find that y equals negative 1. So that creates the point 0, negative 1. And finally, if you plug the x value of 1 in, 2 times 1 is 2, 2 minus 1 is 1, and that creates the point 1, 1. You can then plot these points and draw whatever the equation is. So if I go to negative 1, negative 3, plot that point, 0, negative 1, and 1, 1. And as you can see, if you were to connect all of these dots, I'm going to do my best on this device that I'm using, so apologize for anything bad. I'll just do my best. There we go. We have the equation of a line. So this is what y equals 2x minus 1 looks like. Like I said, and there's nothing wrong with plotting points. If that's the way you prefer to do it, go for it. There's other techniques we're going to look at and remind you about, but plotting points is always a way you can check your answer. All right, what if it's not a straight line? So what about something like this? What if the equation is y equals x squared plus 1? Well, just to keep it very similar with y'all, I'm going to actually use the exact same x values. So I'm going to use negative 1, 0, and 1, and I'm going to plug all of those into my x of my equation so that I can solve for y. So if I start with negative 1, Negative 1 squared is going to be 1, and 1 plus 1 is 2. So that creates the point negative 1, 2. If I plug 0 in, 0 is going to be 0 squared is 0, and 0 plus 1 is 1. So that gives me the point 0, 1. And then if I plug 1 in, 1 squared plus 1 is actually also 2. So you create the point 1, 2. Plot these 3 points right here. So negative 1, 2 is going to be left and up. 0, 1 is just up. And 1, 2 is right and up. And what you probably remember from a previous class, whenever that may have been, is that an x squared represents a parabola. So while it does look like a straight line, that's not what it's going to look like. Anytime you see an x squared graph, and we're going to see plenty of them in this class, you're going to have something that looks like this. It forms kind of like a U shape, but it's called a parabola in this case. All right, another technique that you can use to draw equations is intercepts. So I want to review the idea of x and y intercepts to draw an equation. So if you look, you have the equation in number 3 as 2x minus 3y equals 8. And I just want to know what's the basic graph look like just using the intercepts. All right, so kind of a review part here. I'm going to start with the idea of the x-intercept. So x-intercept means you have a point that crosses this x-axis that runs left and right. The only way that that can be true is if you do not have a y value, or in other words, your y value is 0. So if I let y be 0 in the original equation, so 2x minus 3 times 0 equals 8, that would be 2x equals 8 because the 0 goes away, and you get x equals 4. Now, since x is 4 when y is 0, you have just created the point 4, 0. So I'm going to go over to 4, 0, and I'm going to plot that first point. Do the exact opposite when it comes to a y-intercept. So instead of letting y be 0, for your graph to cross this y-axis, it's got to happen when x is equal to 0. So if I let x be 0 in the original equation, that would be 2 times 0 minus 3y equals 8. That's going to give me negative 3y equals 8. And then dividing by negative 3 is y equals negative 8/3. Now, if you were to type that in your calculator to kind of give you an idea, that's about negative 2.67 roughly. So when I go to plot this, I'm going to go down to about negative 2.7, and that's going to be about right there, just to kind of give me an idea. But for your homework, they're going to, if they ask you to write the point, it would actually be the point 0, negative 8/3. So you've only got 2 spots where this crosses the axis, so it means there's no way this curve bends anymore. So when you only have one intercept on each line, in this case, you have a straight line again. And that is what 2x minus 3y equals 8 looks like. Very good. All right, so since we're going to be dealing with lines a little bit over the next few sections, and especially in the next video, we do a lot of lines. One of the characteristics of lines you may have to do is finding the midpoint of a line. So if you know the endpoints of a line, you can find the point that falls right in the middle by doing the following. Now, it's a 2-part formula. You're going to have to do an x value and a y value of the midpoint. So some books you'll see call this xm and ym for the x and y of the midpoint, but you can find your x value of the midpoint by taking both of your x values in the problem, adding them together and dividing by 2. Likewise, with the y values, you can add the 2 y values together, divide that by 2, and that will be the y value of your midpoint. So when you look at example number 4 here, you have 2 endpoints, negative 1, 7, and negative 3, negative 2. What is the point, if you were to graph this, what point would fall right in the middle of those 2 of a line? So in this case, we can label our first point as x1, y1, and our second point as x2, y2. I'm just going to find each one individually, and then we'll put them together as an answer. So I'm going to find what I'm calling xm, which is the x value of the midpoint. Add both of your x values together. So that would be -1 plus a -3 from the 2 points, and I'm going to divide that by 2. Well, -1 plus a -3, if you put that in your calculator, comes out to be -4, and -4 divided by 2 is -2. Doing the exact same thing for my y values, if I add those together, it would be 7 plus a -2 over 2, which comes out to be 5 over 2, which doesn't simplify. So when you put your answer, as you can see back up here in the formula, it is in an ordered pair formula. So we actually have the point -2 for your x, 5/2 for your y. That is the point that forms the midpoint. All right, so kind of piggybacking off that midpoint idea, can we go backwards now? Or can we find something other than the midpoint using the midpoint formula? Well, here's an example of that. If you have a line segment that has a midpoint of the point 2, 1/2, if one of your endpoints is 7, 3, then what is the other endpoint? So here's the difference here. Normally, you would have an x1, y1, oops, wrong thing, and an x2, y2. I don't know why I wrote 2 first, but that's okay. We can erase that. You normally have an x2, y2. Now, I gave you 1 point, so we can call x1, y1 the point 7, 3. But you're trying to find this other point, which is x2, y2. But if you look, you also know what the midpoint is. And if you go back to the previous problem, we described xm of the midpoint as being x1 plus x2 over 2, and ym as being y1 plus y2 over 2. We can use each of these individually to figure out what x2 and y2 are going to equal. So what is xm and ym? Well, at the very top, since 2, 1/2 is your midpoint, we can say that xm would be 2, that's the x value of the midpoint, and 1/2, which is the y value of the midpoint, we'll call ym. So let's solve each of these. Let's start with the x. So x sub m we know is 2, x sub 1 we know is 7, we don't know x sub 2, and we're going to divide all of that by 2. So on this problem, I'm going to multiply both sides by 2 to get rid of my fraction. That's going to give me 4 equals 7 plus x sub 2. And then if you subtract the 7 over to the other side, you will find x sub 2 is equal to -3. So that's half of your second point. Doing the same thing for y, I can say that y sub m is 1/2, y sub 1 is 3, we don't know y2, and we're going to divide that by 2. Once again, I'm going to multiply both sides by 2 to get rid of the fraction on the right, but nicely it also gets rid of the fraction on the left completely and gives you 1 equals 3 plus y sub 2. Subtract the 3 over, and we can see that y sub 2 is going to equal -2. Put these together in your point up here at the top, and we can say that our second point has to be -3, -2 for the midpoint to be 2, 1/2. Very good. All right. Next thing you want to do, we talked about that if you have 2 endpoints, you can find the point that's right in the middle. What if you have 2 points and you want to know how far they are from each other? This is called the distance formula. So if you were looking for the distance between 2 given points, you can do the formula, the square root, and inside the square root, we're going to do x2 minus x1 all squared plus y2 minus y1 all squared. So let me show you an example of how you would find distance. In number 6, you have the points 1, 5 and -2, 3. So as we saw in the midpoint formula, what I'm going to do is I'm going to call this first point x1, y1, and I'm going to call this second point x2, y2. I'm going to take those four numbers and I'm going to plug them into my distance formula. So I can say that distance is equal to x2, which is -2, minus x1, which is 1, all squared, plus y2, which is 3, minus y1, which is 5, all squared. And we want to simplify this as far as you can, and we're going to not use a calculator in this case. We want an exact answer. So this will be the square root of -2 minus 1 is -3 all squared, and 3 minus 5 is -2 all squared. This would be the square root of -3 times -3 is 9, 2 times 2 is 4, and if you add those together, that becomes the square root of 13. Now you can try if you would like to, but 13 is not going to break down because it is a prime number. So the exact distance between these 2 points is going to be the square root of 13. All right, so that ends section 2.1. Like I told you, 3 sections and they're all rather short. We are now going to move into the last section of this video, which is titled circles. Now we don't do a lot with circles in this class, but there is a section devoted to it. So we're going to do all of our circle information over the next 4 or 5 slides. All right, so first off is what is the standard form of a circle? So to write the standard form of the equation of a circle, you need 2 things every time. If you know what the center is of the circle and you know what the radius of the circle is, then you can write that formula as x minus x1 squared plus y minus y1 squared equals r squared. Now, in the equation of a circle, there's going to be x's and y's. So the x and the y you see with no numbers on them, those don't change. The center that you're going to have can be expressed as the point x1, y1, and then your radius is just the r. So the easiest thing to do is that if you know what the center and the radius are, you can directly substitute those 3 numbers into this formula. So let me kind of show you that on examples number 1 and number 2. On number 1, what if you have a center of 0, 0 and a radius of 7? Well, if the center is 0, 0, that's going to be your x1, y1, and then the r is already clearly labeled as 7. Plug all 3 of these numbers into your formula. That would initially be x minus 0 squared plus y minus 0 squared equals 7 squared. Now, normally, if these numbers were anything other than 0, I probably wouldn't mess with them very much. But when they're zeros, you don't really need them there because subtracting 0 doesn't do anything. So I can actually write this as x squared plus y squared equals, and then 7 times 7 is 49. This is the standard form of a circle given the information above. Now, obviously, not every circle is going to be centered at 0, 0, so we have to know how to deal with that as well. So let's look at number 2. What if you want to write the equation of a circle that's centered at -2, 3 and has a radius of 5? Well, once again, this time we can call x1 -2 and y1 is 3, and as you can see, the radius is 5. And once again, plug all 3 of those numbers into the standard form of a circle. So initially, that would be x minus a -2 all squared plus y minus a 3 all squared equals 5 squared. Now, I don't want you to multiply all this out because you want to leave it in this form, but you do want to go ahead and take care of that double negative. So we know that x minus a -2 is the same thing as x plus 2 all squared. When there's no double negative, don't mess with it. Just leave that as y minus 3 squared, and then 5 squared is 25. This is the equation of a circle centered at -2, 3 and a radius of 5. All right, you should also be able to go the other direction. So instead of me giving you the radius in the center and asking you to write the equation, what if I give you the equation and ask you to find the information of the center and radius? Well, that's fine. So look at number 6. Oh, actually, before I do that, remember, let's look at our general form. We have x minus x1 squared plus y minus y1 squared equals r squared. All right. So when you're looking for the center of these circles, I'm looking for the number that's being subtracted from the x and the y. Well, since there's not a number attached to the x squared, it's understood for the x value of the center to be 0. Since there's a minus 2 next to the y in the circle, we can say that the y value of our center is positive 2. And I say it's positive 2 because the negative is already part of the formula. We saw that on the last one. So your center is 0, 2. The radius, since r squared is part of your formula, since we know that r squared has to equal 36, just take the square root of both sides and you get r is equal to 6. Now you'll notice that I did not do plus and minus 6 because the radius is a distance and distance cannot be a negative value. So we're going to always say the radius is the positive number involved. Good. Number 4 is no different. You have x minus 4 squared plus y plus 7 squared equals 12. So when you're looking for the center of this circle, since there is a minus 4 attached to the x here, I know the x value of my center is 4. But since there is a plus 7 attached to the y of my center, that's backwards, which means you have to do a negative 7 for the y value of your center. In this example, r squared is going to be 12. So when you take the square root of both sides, remember, don't do the negative, you only want the positive. It's the positive square root of 12. But this one actually breaks down because 12 is 4 times 3, 4 is 2 times 2, and since there is a pair of 2's, we can actually say that the radius of this circle is 2 times the square root of 3. Very good. So whether you're given the center and the radius and told to find the equation, or whether you're given the equation, you should be able to find the radius and the center. All right, so how about some basic sketching? Find the instructions for this one says find the center and radius of the given circle and draw a basic sketch of the graph. So it says we have x minus 1 squared plus y plus 2 squared equals 9. This is just like the two problems we just did, just with an extra step of graphing. So first thing I want to do is I want to find the center of this circle. So there's a minus 1 attached to the x, so that means the x value of my center is 1. There's a plus 2 attached to the y here, so the y value of the center is going to be negative 2. So I've got my center for in a second. R squared is going to equal the number on the right, which is 9. And if you take the square root of that, we can say that the radius is 3. So let's sketch this circle. Well, if I know the center of the circle has to be at 1, negative 2, so write 1 down 2. So there's my center. And the radius being 3 means that it's 3 units in every single direction from the center to the outside edge. What you're going to see me do is I'm going to start at the center and I'm going to go in 4 directions. I'm going to go up, right, left, and down, 3 units. So from the center, I'm going to go up 3. 1, 2, 3. So there's the top part of the circle. I'm then going to go right, 1, 2, 3. There's the right-hand side of the circle. Down 3, 1, 2, 3. There's the lower part. And then left 3, 1, 2, 3. And while the center is not actually part of the circle, it's just using it for reference, we're going to connect all of the outside edges, and you can draw yourself a circle. So this circle has a center of 1, negative 2, and a radius of 3, and is represented by the equation given. Very good. Let's do that again. So what about this one? If you have the equation x squared plus y squared equals 9, find the center, the radius, and then extra thing, find the intercepts and sketch the graph. All right, so I'm going to start off the exact same way. Let's start off with the center and the radius. But you'll notice that there is not a number being added or subtracted from the x or the y. That's actually okay. That just means that the center of your circle is going to be 0, 0, or the origin. Just like the last one, just a coincidence here is that r squared equals 9, so therefore r equals 3. Now, I'm actually going to skip the intercepts for a second and you'll see why. We know how to sketch the graph from this information. If the center is 0, 0 and the radius is 3, I can just go 3 units in the upward, rightward, downward, and leftward direction, and I can draw myself a basic circle. Not beautiful, but it gets the job done. And the reason I went after that, because now you can answer that fourth question that we didn't talk about in the last one. Find the intercepts. So remember, the intercepts is talking about the x-intercepts and the y-intercepts. So now look at your graph and write down the points where it crosses the x-axis. It crosses the x-axis at -3, 0 and 3, 0. That is this point and this point. So those are the x-intercepts. And then it also crosses the y-axis twice, which would be 0, 3 and 0, -3. Those would be your y-axis or y-intercepts. There's no need to do any fancy algebra. In some cases, just drawing the graph first makes it easier to recognize the x and y intercepts. So very good. All right, and then just one more just like that. Let's talk about when the center is not 0, 0. That way, because the intercepts may not be as easy to find. So here we go. Number 7 says you have x squared plus y minus 2 squared equals 4. So let's do the 3 parts we know and are very comfortable with. Number 1, find the center of this circle. So there's no number attached to the x, so that will be 0. There's a -2 attached to the y, so that would be 2. So there's the center of my circle. All right. Your radius, or in this case r squared, is 4. So if I take the square root of both sides, I know the radius is 2. All right, so let's plot our points. If you have a center of 0, 2, and you need to go 2 units in every direction. All right, so we're going to go 2 units in the upward direction, so that's to here, 2 units in the right direction, 2 units down, and 2 units to the left. All right, so draw your circle. It's a little bit smaller because remember, the smaller the radius, the less you have to draw. But there is a basic sketch of your circle. Now the question is, can you tell where it crosses your axis? Well, let's look. Let's start with the x-intercepts. Where does it cross the x-axis? Well, the only time it crosses the x-axis is right there at the actual bottom part of this circle. That's actually at the origin, which is 0, 0. That is your only x-intercept. Now, as far as the y-intercept goes, that first point you just wrote actually doubles up as a second answer. If you're looking at the y-axis, that's also a spot where the circle crosses the y-axis. So we cross at 0, 0 on that as well. We also cross the y-axis up here at this 4, so that's going to be the point 0, 4. So this is an example where the graph only crosses the x-axis once, but it does cross the y-axis twice. So you got to be careful that don't assume that everything has the same number of answers. All right, so that ends this video on sections 1, 9, 2, 1, and 2, 2. We talked about how to solve quadratic inequalities. We did some basics on some graphing lines and parabolas. We looked at midpoint and distance, and finally we looked at circles. In the next video, we're going to actually finish up the midterm exam material, and we're going to do sections 2, 3, and 2, 4. We're going to dive into a lot more details about lines and what you can do with those. So I will see you in the next video to talk about lines.